All right. Good morning, JDevSummit IL. It took us an extra 4 months, but we made it. And that's not a trivial feat. So let me just quickly go ahead and present myself. My name is Yaniv Nahoum. I'm 47 and married. I have a couple of beautiful children, and I'm a tech coach at AT&T here in Israel. And when I'm not reading code, writing code, or talking about code, you'll find me running a lot. And I'd like to kick this session off by taking you to a stroll down memory lane, a whole decade back to March 2014. That was when Java 8 was released. It was a pretty sizable release. It contained new features and new APIs. And 3.5 years later, Java 9 was released. And that marked a salient change in Oracle's release strategy. Basically, we started getting releases every 6 months, every March and September. And so we quickly found ourselves with Java 11, and then six releases and 3 years later, Java 17, and then only a couple of years and 4 releases later, Java 21, and here we are today. And Java 8, 11, 17, and 21, they're all LTS versions. That stands for long-term support. That means that Oracle basically supports these versions for many years. Depends on the version, but for many years. And throughout this period, they deliver security patches periodically. They apply bug fixes, and even some bugs are backported from future versions. And this is in contrast to the non-LTS versions, which once a new release is out, they are, so to say, superseded, and they get no fixes, no security patches, and should actually not be used. Okay, so we're now in April, and actually just over a couple of weeks ago, Java 22 was released, but since that was a non-LTS version, we'll be talking today about Java 21. So let's do a quick show of hands to see what you guys are all using in production. And if you have a few different versions, then if you're using a few different versions, then what happened? If you guys are using a few different versions, then just vote for the latest version that you have in production. So with a show of hands, who's using Java 21 in production? Some of you, not a lot. Who's using Java 17 in production? Oh yeah. How about Java 11? Still some of you, Java 8? It's 10 years old, guys. How about other versions? Any other versions being used? Okay, one brave guy here. So I hope it's Java 22. But no, it's not. Okay, then I definitely hope it's not one of the other non-LTS versions, because, as I said, they shouldn't be used. They have been superseded. And in total, there were 22 JEPs that were released between JDK 17 and 21. And at this point, you're probably asking, what in the world is a JEP? Well, a JEP is a JDK enhancement proposal. It's basically a proposal to add a feature to the Java language, and these features are the mechanism through which the Java language evolves with time, and the collection of all JEPs basically form the roadmap for the Java language. And these JEPs come in different shapes and colors. We have things that are added to the language. We have things that are removed from the language, not in these specifically 22 JEPs, but we do have deprecations For example, we have the Windows 32-bit x86 port that has been deprecated and will be removed in later versions. But obviously, we're more interested in the additions, and there are quite a few different additions to different parts of the JDK. We have additions to the hotspot JVM. For example, the 0GC garbage collector has now been made generational. So that's a nice change. Obviously, we have language changes, and I'm going to expand on that during this talk. We have changes to libraries, such as the fabulous project Loom, which I'm sure you've all heard about, virtual thread, structured concurrency. Actually, on this very stage a year ago, Chaim gave the keynote and talked about Project Loom. So if you didn't catch that, you could probably find it on YouTube. And we have changes to additions to tools, such as JWeb server, a CLI web server, and Java.IL snippets that allow us to embed example code in our Java.IL with more ease. So we're going to be talking about the language changes because as developers, it's really what makes us tick, and it's the most interesting thing for us. And there were 5 language JEPs integrated between Java 17 and 21. We're going to be talking about the first 4. The 5th has some educational value, but mostly it's not of a lot of interest to experienced developers. And I assume that you notice that 2 of these are labeled with the word preview, and that requires an explanation. So preview features are Java features that have been fully specified, fully implemented, but are not yet permanent. They're introduced into the JDK to provoke feedback from the community and to gather that feedback, then act upon that feedback and reintroduce these features either for another iteration as a preview or sometimes just by making it permanent, with or without changes. Now, since Java 22 has been already released, we can get a glimpse of the future, and we know how to handle these preview versions. And I can gladly say that the unnamed patterns and variables has been made permanent with no changes, and the string templates has been reintroduced for another iteration of preview, but with no changes, which is great because it gives us more confidence if we decide to use these preview features. Now, just some technical stuff about using the preview features. In order to use them, you need to pass a flag both to the compiler and to the runtime. Okay, so for example, if you're using Maven, you can see up on the screen how you can specify it to the compiler and how you can specify it to the Surefire plugin in order to run your tests. And for the runtime, it really depends on how you launch your application, but I can recommend on one way of doing this, and that's by assigning that value to the Java tool options, which is an environment variable that the JVM detects very early in the life cycle. It picks up this environment variable and uses it. Great, so we're going to start with record patterns, and we're going to just touch upon unnamed patterns as well. So let's go. I'd like to remind you of a nice feature that we got in Java 16. Most of us used it first in Java 17, the LTS version. And let's take a look at this method, print in uppercase. I'm sure this is very familiar to a lot of you. We had this annoying problem that if we check if an object is an instance of string, then we wanted to print that string in uppercase, we first had to go through this very annoying ceremony of casting the object to a string before we can use it. Now, pattern matching for instance of allowed us to do this in a more concise manner just by adding a pattern variable and then using that variable exactly in the scope. Another thing that I want to remind you of are Java records. So say I have a coordinate with an x and a y, and I want to model it as a point, an immutable point with a constructor, accessor methods, and the standard equals hash code and toString. Since JDK 16, I can now write that as a record point which is not only more concise, but it also conveys my intent that the point is a carrier of data and nothing more. So that was, I'm sure you all use records a lot, but now in JDK 21 we have record patterns. So let's see what this solves. And the first pretty simple example is this method printSum that accepts an object. I go ahead and check if the object is a point P, and I'm using pattern matching for instance of here. And then take a look at this part. I extract X and Y in order to print their sum. Okay, but what I'd like to do is expand the pattern and destructure my record in order to be able to use X and Y directly in the scope without having to extract them. So that's what record patterns let me do. Now, record patterns really shine when we have nested record patterns, and this could be arbitrarily deep. So in order to demonstrate this, I'm going to complicate things a bit, but not too much. So we have an enum color with red, green, and blue. We have a record color point that has a point and a color, our enum from the row above. And we have a rectangle that is defined by 2 points, the upper left colored point and the lower right colored point. And the lower right color point, yeah. And let's take a look at this method. I want to print the color of the upper left point. So one thing I can do if I have an object is check that it's an instance of rectangle, and I go ahead and destructure my rectangle into a colored point upper left and a colored point lower right. I can then go ahead and use the upper left and extract the color from it. So this does the job. But what's nice is that colored point in itself is a record, so I can do even better by destructuring it further. And in this example, we can see that the upper left colored point is further destructured into a point and the color, and then I can use the color directly. So this is already much better. For me, this code is a little bit too noisy though, and we can reduce the amount of clutter that we have. For example, if we introduce var instead of the type itself. So this is better, right? I mean, var color, we don't have all that clutter, but still, notice that the point and the lower right, the whole lower right colored point are unused. We're not interested in them. And this brings me to the other feature that I presented before, the unnamed pattern. So finally, Java gets the unnamed patterns, like many other languages that we know, and we can use the famous underscore to say, we don't really care about this, we don't want the clutter, we don't want to see it. It's very, very clear what we're interested in now, which is the color, and we use it in the scope. And note that nothing is bound to these underscores. Okay? That's why we can have more of them in the same statement. So it's not like in the scope, I can write underscore dot something. No, you can't use it, which is great. Another thing I want you to note is that in this case, the underscore replaces both the type and the name of the variable. There's nothing there. Okay, we'll see another example later on. Of course, sometimes record patterns don't match, and so let's see an example of that. Say I have a type pair, which has two objects of any type, and I have a concrete instance that has two ints. Now, if I were to check if the pair is an instance of, if my object is an instance of pair with two strings, and then if it is, I'd like to sum their length, I would obviously go to the else clause in this case. But note what's happening here. We're getting centralized error handling because there are three matches to be made. First, I want to check that it's a pair. Then I want to check that the first variable is a string, and then that the second variable inside is a string. So there are three checks. Obviously, with other expressions, it could go much deeper. And the nice thing is that the pattern either matches or it doesn't match. So we get centralized error handling, which makes things much simpler to reason about. So that's it for the first feature, record patterns. Let's move on to the second one, the pattern matching for switch. It's a long one. There are quite a few details here, and we're gonna touch upon the unnamed patterns and variables again in this one. For the following examples, I'll need some kind of hierarchy, and I'm going to use this simple one. So I got an empty interface, and I have three children that are implementing it: a cat, a dog, and a bird. Note that each one has a different method, which represents a sound that the animal makes. So I have meow for cat, bark for dog, and chirp for the bird. And if I were tasked with writing a method called communicate, that accepts an animal and then returns the sound that the animal makes. One possible implementation would be the one that you can see up on the screen right now, in which I use the if, else if, and I go through all my possible implementations. I use pattern matching for instance of to extract my animal. And then I call the right method, so dog.bark, cat.meow, and bird.chirp. And if it's not one of these, I can throw an exception. Now, while this implementation is not bad, I can still see two main shortcomings here. The first one is that, unfortunately, the compiler doesn't really protect me if I forget to assign a value to message. Now, while it is true that I can omit the first assignment of string message of null to the string message, and then the compiler would warn me, but a lot of developers don't write code that way, so it's not foolproof, and that's a shame. And the second thing is performance. Performance in this code is more or less linear, and we would hope for something that is closer to constant, of a big O notation of 1. And we're not getting that. So starting with JDK 21, we can write this. So now we can switch over any reference types, not only string and enum, any reference type, and we can actually use a pattern to match the type of that reference type. So you can see that we now have a branch per type. It is very clear. My intent is very clear. I get better performance because it's a switch. And since we're using switch expression, but even with switch statements, the compiler protects me. I can't go wrong here. There's no way that I'll forget to assign a value. I also have a default clause in this expression because the compiler insists on it in this case. Now, I don't know about you, but I've always been bothered by the fact that if I want to handle null in a special manner, I need to do it before the switch, right? Because if I switch over null, I get a null pointer exception. So in this case, I wanted to return not applicable if I get null, and I need to do it before the switch, which it may have been reasonable when we could only switch over string and enum as reference types, but I don't think it makes sense anymore. Which is why now in JDK 21 we get a much more streamlined experience. We can insert the handling of null as just another branch in our switch. Okay, so look how beautiful that is. And of course, case null can't be combined with other labels. It doesn't make sense, right? I mean, think about it. If I have case null and cat, what would get assigned if my animal is null? What would be assigned to cat? So it doesn't make sense. I can't combine it with other labels except the default clause. That's rather common, right? That I would like to handle the default case with the null case, and that is possible, and it's done this way. And only this way, only in this order. So case null and then default. So let's move on. Another thing that is quite annoying, I think, is that I can't remove the default clause. I mean, my domain consists only of cat, dog, and bird. But the compiler doesn't know it. And since it doesn't know it, it gives me a compiler error. You haven't gone through all possible types. But I have gone through all possible types, you just don't know it. So let's see how I convey my knowledge to the compiler. Well, it's really simple. It's a feature that we got in JDK 17, sealed classes. And I know that most application authors haven't used sealed classes, sealed hierarchies a lot. I think mainly because we didn't have too much to gain from it. But I think now we have something else to gain from it. And let me just remind you a bit about sealed classes. So once I have a sealed parent, the children must be derived directly from that parent, not through another class. And another important thing is that the children need to define how they propagate the sealed hierarchy under them. So in my case, you can see that cat, dog, and bird, all three are final, meaning they're leaves in my object graph, and they cannot be derived from. But there are other possibilities. I can define that one of my children is sealed in itself, and it has its own sealed hierarchy under it. Or the child can even say that all bets are off, he's out of this game, and declare itself as non-sealed. So it's basically open under that specific class. So all these are possibilities. And now that I defined this hierarchy as sealed, I can remove the default clause because now the compiler knows what I know, that these are all the possible types. So this is what's called an exhaustive switch. We know this from enums, right? For enums, we could have already done this. Now we can actually do this with classes. So this is great. Now what happens if I don't really want to use the type that I'm matching on? So cat, I want to return pet. Or even if it's cat and dog, I want to return the string pet. What happens in this case? Well, in this case, we get a compile time error because you can't combine these labels. And if you think about it, it doesn't even make sense. I mean, if the animal is a cat, then what do we expect to be assigned into the dog variable? If the animal is dog, what do we expect to be assigned in the cat? So it's a problem because we really want to write this code. And again, what comes to our rescue is the new unnamed patterns and variables. So note the underscore in these two cases. Since nothing is bound to the underscore, to the unnamed pattern variable, we no longer have a problem here, and we can write this code as is. And remember that before we saw the underscore replacing both the type and the name of the variable. In this case, it's just the name because we need the type. That's what we're matching on. Okay, so make note of that change. So let me go ahead and complicate things just a bit, not too much. Cat and bird remain exactly the same, and there's a change in the dog. It has now become a record, and I added a header component, a field called barks per minute. So I have noisy dogs that bark a lot of times per minute. I have very silent dogs that hardly bark at all per minute. And note that since it's a record, I no longer have to describe how I propagate my hierarchy because records are implicitly final. So that's why they combine really, really well with sealed hierarchies. Let's see how this changes my switch expression. So again, cat and bird branches remain exactly the same. Whereas the dog branch is a bit more complicated. So I start off by extracting the sound that the dog makes, and then if I have a dog that barks 10 times or more per minute, I want to return the sound in uppercase. If on the other hand it's less than 10 but more than 3, I just want to capitalize it. Otherwise, I'm going to return the sound as is. Note that I'm using yield here. Yield, guys, is used only in switch expressions and not in switch statements. Okay? So we have break that is used in switch statements and yield that is used in switch expressions. And we use it when we have multiple statements, so we need a block, and then we want to return something from that block. Okay, obviously, if you have a single statement like we do for cat and bird, there's no need to use the yield keyword. So trying to reason about this code, it's not bad, but it's kind of a shame that I started off with one paradigm, the switch, and then I had to switch, no pun intended, to if, else if, else if. So it's kind of a shame. What I wanted to do is to have a branch for each one of my cases. And with JDK 21, I can now do that because we now have guarded case labels. So guarded case labels, how does that work? Basically, I match on the type, and then I use the when keyword. That's a new keyword. And to the right of that, I put a Boolean expression. Okay, it can be as complex as I want, but I put a Boolean expression. So so if it's a dog, when dogs barks per minute is greater than or equal to 10, arrow, and then I convert it to uppercase. And I do the same logic as I did if it's greater than 3. Otherwise, if it's just a plain old dog, I return the sound as is. And one thing that I want you to note here is that the compiler checks for dominance of case labels. Now, what does dominance mean? So in order to explain dominance, let's look at another example that we already know pretty well. Let's take this method that throws an exception and say I have 2 catch blocks. Okay, one that catches an illegal argument exception, I want to log one thing, another one that catches an exception, and I log another thing. Now, what would happen if I switched these blocks? Obviously, it wouldn't compile. And we're not surprised by this. I mean, it makes sense. The exception that some method that throws will get caught in the first catch block, and the second is basically dead code. It can never reach there, right? So the same logic goes for guarded case labels and unguarded case labels. If I have the unguarded case label above the guarded case labels, I can never reach the guarded case labels because any expression will get caught, so to speak, in the unguarded case label. So this is something that you need to take note of. And all together now, we're going to see record patterns with pattern matching for switch and the unnamed pattern, so hold on to your seats. We're going to switch over our famous rectangle from before, okay? And I'm interested in 3 unique types of rectangles. The first one is rectangles in which the upper left point is in the origin, okay? In the origin, Bereshit Hatzirim, for those that are don't know the term. So we have a rectangle with a colored point. I extract the only thing that I'm interested in, which is the colored point, and specifically the point of the colored point. I don't care about the color, so I'm using the unnamed pattern both for the color and for the whole lower right colored point. Then I use a guarded case label when, and I can check. I already extract x and y. Note that in the expression itself. I check that, I make sure that x and y are both 0, and then I can print out the upper left is in the origin. In the exact same manner, I check that the lower right colored point is in the origin. Same thing, only I'm not interested in the whole upper left point, and I'm not interested in the color of my lower right point. And the third type of rectangle that I'm interested in, the family of rectangles that I'm interested in, is those rectangles whose colors of the colored point are equal. So again, I'm not interested in the point itself. I only extract the color. I destructure my color point, and I'm only interested in the color. And then I can go ahead and check. It's an enum, so I can use equals equals and make sure that the colors are the same. Of course, I haven't gone through all the rectangles in the world, so obviously I need a default clause, and I add one. Okay, otherwise it won't compile. So there we have it. Pattern matching for switch. It was a long one. Switch learned quite a few tricks. I hope you got most of it, if not all. And that brings us to our last feature of the day, string templates. Now, string templates is something that I, for one, have been waiting for a long, long time. Let me present the issue at hand. So, say I have a couple of ints, x and y. they're equal 2 and 3, and I would like to print out or log 2 plus 3 equals 5. Okay, so I have quite a few ways to do that in the Java language. One is a trivial string concatenation. Okay, pretty good performance, terrible readability. You can see that it's hard to distinguish the plus that concatenates from the plus inside the string literal. Sure, the IDEs help us by highlighting the text differently, but still, it's not a pleasant experience. Another way we can do it is with string builder. Okay, it's extremely verbose, doesn't help readability that much, and performance is exactly the same as before. I guess we'd save the string builder for cases in which we have to dynamically build strings in a loop or stuff like that. We wouldn't use it otherwise. Another option that's on the table is string.format. And we have the static version. We also have the newer instance version formatted. And in both cases, we have what's called format specifiers, the %d, %s, and so on and so forth. So we have the placeholders and we have the values. And that is exactly the problem with this, that it's not great in terms of readability, and it's a bit error prone. So I can forget to provide all the values. And when I look at the code, I read it and I try to understand what's going to come out, my eyes go back and forth between the placeholders and the values. Again, not such a great experience. And we all know how this is solved in other languages. I mean, almost any language that I can think of, Python, Kotlin, Groovy, C#, Swift, JavaScript, TypeScript, they all have string interpolation in one form or another. So how does JDK 21 solve it? Well, I'll show you in a bit, but it's not only string interpolation. Let me say that up front. So in Java, they decided to solve this problem, but do it in a more robust way and in a safer way to address other problems that string interpolation introduces. So let's see, first of all, what it looks like. So it looks like this. Let's break this down. We have a template processor. That's the str. Okay, the str, we don't have to import it. It's implicitly imported, statically imported, to every Java file. Okay, so we can just use it, and then dot, and then we have the template, the string template, which is basically a string that has template expressions. Okay, and a template expression is an expression that starts with a backslash and then curly braces, and inside the curly brace we have any expression that can yield an object, because every object has a toString. Okay, so anything that can be printed out. So as I said, any expression. We can have x, y, but we can also have x plus y, and we can even have method calls. Okay, we can even break it into multiple lines of code if we want. It's all good. Okay, and you may be wondering why in the world Oracle decided to use a backslash curly brace and not the famous dollar curly brace. Well, I think at least one of the reasons is because you want to distinguish between regular strings and templates, and dollar curly brace is actually valid in any string, whereas backslash curly brace, you can't have a string that has that. Okay, it just won't compile. So that's a good thing. They're easily distinguishable. Of course, text blocks work too. So who hasn't written this in production code or even test code? You know, when you need a lot of different examples of a JSON fixture, and you want to use it every time with a different value. So instead of now either doing this with formatted or with a replace, replacing the tokens inside, we can just use string templates, and the code is clearer and easier to maintain that way. Another thing we may want to do is explained in this example. So say I have an array of items, and each item has a key and a value. and I'd like to print it in tabular format. So I can try and do something like this. I would end up with this sad table. So I'd probably need to add some format specifiers, right? Format specifiers are exactly what I need here. And to do that, I need to make two changes. So first change is I need to change my, my str to FMT, which is also built in the JDK. Okay, it's exactly like the str, but it also supports the parsing of format specifiers. And I add my format specifiers. In this case, I have the -8 to add write padding, okay, up to 8 characters, and I have the S for the string. And then, behold, my beautiful table, and this is how it's done. So I mentioned before that one of the goals of this feature was not only to perform string interpolation, but also to resolve some of the problems that arise from string interpolation that are related to safety. I think the classic example that you can think of is of SQL. So if I get a SQL query and I want to add in the placeholders, I'm exposing myself to SQL injection, right? That's like the classic mistake, and we use prepared statement for that. But other cases may be that I want to create a well-formed JSON object, and I need to first create the string, then validate it and sanitize it. And so string templates allow us to write custom template processors. So let's see what that looks like. So how would we do it before, okay, without using custom template processors? Let's say I have this text block of JSON, and I have name, phone, and address. So I create my string of JSON, and then I'm going to use Jackson just because I use it a lot. And I'm going to call JSON-mapper.readTree and get a JSON node. Okay, so that's my goal. I want to get some JSON, and I want to get a JSON node back. Okay, so this is a process that I have to go through, and obviously, in all my code, in every class in my code where I do this, I'm going to inject the object mapper or the JSON mapper, right, in order to do this. So let's see if we can make this a bit better, okay, and include this whole logic of because the validation is done by the object mapper here. So I want to include that logic and streamline my code. So I can do that by first specifying a function that receives a string template and returns my target object. My target object is a JSON node, okay, but it can be anything. Okay, so this is exactly the code that that you saw before. So JSON mapper.readTree, and to get, once I have a string template, which is what we saw, the string with the template expressions, if I want to get the result of that, I call string template.interpolate. Okay, so that gives me a string, the final string with the placeholders, and that's what I'm passing to Jackson. So that's the first stage. Then I write my custom template processor, and just note how easy it is. So I'm using the factory method, string template.processor.of, and I'm passing it a function, the function that we have here above. Okay, so we need a method that translates from string template to your target object, and our target object is JSON node. And once we do that, we no longer now have to inject our JSON mapper, our object mapper, to every class, because all we need to do now is use our custom template processor, just like you see here. So JSON dot and provide a string template, and the result node is no longer a string like we have for str. It's JSON node. Okay. So that's it, guys. We went through record patterns. We went through the unnamed patterns and variables, pattern matching for switch, and finally the string templates. So I really hoped you learned something today, and all those that didn't raise their hands when I asked about Java 21, I hope that next conference those hands will be up and you will all have been migrated to Java 21. So thank you very much.